I want the airplanes that are called guppies to be named after the Muppets with the yip yip mouths.
No.
You know?
Do those Muppets have names? The Yip Yip Muppets?
I'm not a Muppets person, but they're my favorite of the Muppets.
That made me think of the characters in SpongeBob that are like, meep. You know?
I wonder if they were inspired by. Welcome to AirSpace from the Smithsonian's National Air and Space Museum. I'm Emily.
And I'm Matt. A long time ago, before we had our modern storm tracking technologies, a guy, egged on by his buddies in a barroom bet, took a small training plane and flew it through a hurricane.
It turns out flying through a hurricane really helps in predicting its path and intensity, which is useful to anyone who happens to be battening down the hatches and trying to decide if they should evacuate.
Today, two groups of aviators from NOAA and the Air Force fly hurricane hunting missions back and forth through the eyes of hurricanes. We talked to some of them and found out what that's like. Today on AirSpace, sponsored by Lockheed Martin.
Hey, Airspacers, we need to pop in here just for a second and let you know that we had some minor technical issues when recording parts of this episode. Later on, some of the audio is noticeably different. We know. We're sorry about that. Thanks for understanding.
I grew up mostly in the desert and in the Midwest, so hurricanes are not something that I really grew up with. Although one time when I was visiting a friend in Charleston, there was a hurricane that got me stuck in my hotel for an extra night and unable to fly out. So I did have that one hurricane experience. But we have someone with us today who is a hurricane expert who comes from hurricane country, Sophia Soto Sugar.
Sophia!
Hello. Yeah, it's me, the hurricane expert from hurricane country. I'm honored to be here, really.
So, Sophia, you have been part of AirSpace for a really long time, and folks would know you also from the miniseries that we did called Queer Space.
Yes, and also the other one, Aerospatiale. It's nice to be back at the mic. But more importantly, I think, is the fact that I'm a diehard Floridian. Like, I could come in here with absolutely no airspace experience and still be equally excited to talk about hurricanes.
So flying through a hurricane seems like a really crazy, ridiculous thing to do. Like, my intuition would tell me it'd be like the worst, choppiest, most dangerous thing ever to do. And, you know, it did take kind of an unusual circumstance to get the first airplane into a hurricane.
Right, so it turns out that the very first flight through a hurricane was done by someone in the Army Air Forces during World War II. That legacy is continued by the 53rd Weather Reconnaissance Squadron of the Air Force. One of the members of this squadron is Lieutenant Colonel Mark Withee.
I'm a navigator with the 53rd Weather Reconnaissance Squadron, more commonly known as the Hurricane Hunters.
It was Mark who told us the story of how that first plane ended up in the hurricane. And as it turns out, as we mentioned in the billboard, the original hurricane flight started as a barroom dare in 1943.
There was this guy, Colonel Joe Duckworth. He was in Texas, and kind of on a bar bet, he went out and flew a single-engine trainer through a hurricane for the first time and proved that it could be done.
I think what's wild to me about this barroom dare is that nobody, including Duckworth's superiors, thought he was going to make it out alive. And I don't know what kind of planet this is. I don't know. I don't do any barroom bets, clearly. But the notion that you're going to encourage somebody and then expect them to go through with this dare that nobody thinks you're going to survive feels weird to me. But he surprised everybody pleasantly. For me, I don't like a tragedy. Surprised everybody by succeeding in flying through this hurricane and then telling everybody about what it was like.
Yeah, and I'm just having a lot of fun imagining the context of this bet. Like, were they in a bar where a hurricane was starting to bear down on wherever they were, and it's like wind is whipping around outside, rain is just pelting the windows, and this guy's like, I bet I could fly in that.
And also, you would think that a dare has like a $10 on the other side of it if you complete it, but this feels really high stakes. What was
Very
to
high
come
stakes,
at the end of this?
Well, and I think the timing of this is really interesting, too, because while in my brain I was picturing the bar in obviously the movie The Right Stuff that Pancho Barnes opens.
Of course.
This is really important to remember because we hadn't even started putting things into space yet. And so we didn't have things like weather satellites letting us know that there was really bad weather heading our way.
Yeah. But then, when he succeeded in flying in that storm, immediately it became obvious how valuable this could be, right? Incredibly valuable to the Navy, who has a lot of assets out at sea, incredibly valuable to the Air Force, who has a lot of stuff in the air, but then also valuable just to the U.S. coast and everyone who lives on the coast in terms of providing them with all of the information they need to survive whatever storm is coming.
At the same time, kind of on the other side of the world, you have World War II raging, battles in the Pacific, and Admiral Bull Halsey had his fleet out in the Pacific, and they were caught unexpectedly by Typhoon Cobra in the Pacific, and that sunk, I want to say, 3 ships, and there were something in the order of 700 sailors that were lost, and hundreds of aircraft. And at that time, there was no satellites. We did not have a good way to predict where typhoons or hurricanes may be at. And it was a significant potential impact to any war effort. So after it was shown that you could fly through, interest increased significantly in conducting airborne weather reconnaissance. And there were multiple squadrons started, both the Air Force and the Navy. There were, throughout the late 40s and 50s, there were multiple squadrons. But satellites have taken over, in many cases, the role of getting a big picture, global view of what's going on. The role of actual aircraft reconnaissance and weather has diminished, but ultimately for storms that are impacting the U.S. or the Western Hemisphere, there is really no replacement for flying through them and gathering the data to put into the models.
So after World War II, the Army Air Force became the Air Force, and the Air Force took over the military side of hurricane flying.
Fast forward 80 years to where we are today, and flying through a hurricane still remains impressive, but it looks a lot different than it did in 1943.
So the airplanes that are used by folks like Mark to fly through hurricanes are the Lockheed C-130 that's been modified to be a hurricane airplane. And specifically, his plane is a WC-130J Super Hercules aircraft. And these are pretty big turboprop planes, maybe about the size of a 737. And the best way to think about what a turboprop plane is that whereas a jet airplane, like your regular commercial airliner, is going to push you forward, a turboprop is going to pull you forward. That's how the different engines work, approximately. I'm not that kind of scientist. So a turboprop like the C-130, if you've never heard of one, is the kind of airplane that's used a lot for transporting big loads of people or big pieces of equipment, among many other kinds of things.
And the Air Force isn't the only group that flies hurricane hunters. NOAA, the National Oceanic and Atmospheric Administration, also flies 2 different types of hurricane hunter missions. And of course, we talk to them too.
So I'm Commander Kevin Doremus. My current role is an aviation advisor to our 1-star admiral in the NOAA Corps, and I'm a hurricane qualified aircraft commander on the P-3 Orion Hurricane Hunter aircraft.
So one type of NOAA mission is pretty similar to what you just said the Air Force is doing. The NOAA pilots fly 2 Lockheed WP-3D Orion aircraft, also large turboprop planes. They are adorably nicknamed Kermit and Miss Piggy. NOAA also has 1 Gulfstream G4 jet named Gonzo, which flies high, and it's around and ahead of the hurricanes rather than through them.
I'm Lieutenant Thomas Smith. I'm a commissioned officer with NOAA, the National Oceanic and Atmospheric Administration. Started flying the Twin Otter, flew that for about 3.5 years before I started flying the G4, and I've been flying that for about a little over a year now. So we fly kind of larger reconnaissance patterns around the storm itself, but also ahead of the storm. So sampling those areas of the ocean and the Gulf that don't have a lot of surface observation sites.
So both Kevin and Thomas are officers in the NOAA Corps, one of the United States uniformed services. And I think this is really interesting because for me, this is brand new information about a year ago, that there's 8 uniformed services, 6 of which are military branches. That seemed like normal information for me. But these 2 additional uniformed non-military branches include the NOAA Corps. The other is the Public Health Service Commissioned Corps. The NOAA Corps is made up of just over 300 commissioned officers as well as civilians that work within the NOAA Corps, just like there's civilians that work within the military branches. So what I think is really interesting about all this hurricane hunting is that it's not something that's necessarily the responsibility of one particular organization or group, and that it's done between NOAA and the Air Force really collaboratively.
Yeah, and really they're not just doing this in their own service either. They're getting their tasking and providing information to 2 other organizations, the National Hurricane Center and the Hurricane Research Division, both of which are divisions of NOAA.
Like you mentioned, it's not just me looking at the tropics and being like, yeah, we should probably go look at that. I'm way, way, way lower in the food chain. That decision is made, leagues of pay grades above me, somewhere in Miami, I'm sure, at the Hurricane Center. But the National Hurricane Center tasks us with hurricane reconnaissance flights. And there's also an entity called the HRD, the Hurricane Research Division, which the taskings are slightly different in that the HRD taskings are more on a research basis. You might fly a storm that doesn't necessarily threaten, U.S. property or U.S. interests, but it's just maybe a unique storm, something that has just rapidly intensified or something that they're not quite sure is going to become a tropical storm, for example. Whereas the NHC taskings are, okay, we have a storm, it's likely to impact Puerto Rico, for example. We need to go fly it to get a better understanding and improve the forecast.
Between NOAA and the Air Force, there's 3 types of planes and 3 crews unique to each type of plane. NOAA's Kermit and Miss Piggy have the biggest crew of those 3.
And Kermit and Miss Piggy are the WP3D, also known as the P3.
The P3, where I fly, we have a little bit of a bigger crew, 18 to 22 on average. We have kind of our NOAA crew. That's a crew that's kind of responsible for making sure the plane is mission ready and flyable. So we've got pilots, flight directors, which are in-flight meteorologists, flight engineers. It's a civilian position that sits up in the flight station that are managing a lot of the aircraft systems. We have a navigator. We have what we call IFTs, in-flight technicians, that are on board the aircraft, making sure everything's running. If it breaks in flight, we have the people that essentially built the airplane with us, and they can fix it as we're flying. We have people in the back, we call them our AVAPS operators. So that's our Airborne Vertical Atmospheric Profiling System. Fancy word for the people that launch stuff out of the airplanes, specifically our dropsondes and some of our air-launched uncrewed systems. And so that's kind of like the NOAA crew. And then we've got visiting scientists from universities, from the Hurricane Center, from the Hurricane Research Division. Every now and then we'll bring a media writer on board. But in general, the plane's pretty stuffed full of people there to get the mission done.
Kevin just mentioned a dropsonde, and you're going to hear that word a lot in this episode. So to break it down a little bit, sonde, it's a French word that means probe, and dropsondes are a type of radiosonde or probe that transmits via radio signal. And they're called dropsondes because they are literally dropped into hurricanes to gather and transmit data used to make weather predictions. So we're going to get into all of that later, but for now, just know that when we mention sondes or dropsondes, that's what we're talking about. Mark's crew and the 10 other crews that fly missions for the Air Force are made up of 5 members. There's the pilot, the co-pilot, the navigator like Mark, flight meteorologist, and then the weather reconnaissance loadmaster. And sometimes there might be another scientist or some members of the media who might join, but for the most part, it's those key 5 members.
The C-130, it's a 2-pilot aircraft, so you'll have an aircraft commander and a co-pilot. They're going to be up there flying the aircraft. As the navigator, I'm using the radar, coordinating with the weather officer in the back. So that's the 3 crew members that are up front. When you move to the back of the aircraft, you have the loadmaster, and they're really focused on dropping the sondes and getting that data from those critical points and then passing that over to the weather officer. And they're really the sort of mission coordinator. They're looking at their specialized instrumentation to help us find the critical points in the storm where we need to be gathering that. So it's a basic crew of 5. For some of the longer missions, when you're flying overnights, we will augment the crew with additional pilots or other crew members as necessary. But the base crew is 5.
Whereas the NOAA G4 crew varies a little bit more, but it's generally around 8.
So we fly with at least 2 pilots, sometimes 3. There's a jump seat in between the 2 pilots. We have usually 2 flight directors, some technicians and flight technicians that help with the tail Doppler radar, as well as the sound launching, as well as engineers who could also be helping with sound launching. A lot of times there's, for example, a veteran flight director that's training a new flight director, and it's just kind of like continuity of operations. So that's the typical crew complement.
We'll put pictures of the planes on our social media for good comparison. So for me, as a person that has experienced hurricanes and also does not really understand how planes work, I did fully assume that they were extra beefed up, like jacked up planes.
100%.
They are hunky beefy.
Right. Because on the ground, right, for a structure to survive a hurricane, it has to be kind of specially reinforced. You see people putting all kinds of barricades and plywood on the windows and things like that. So you would think that maybe the same thing applies to if you're going to fly through the thing.
Yeah.
But no.
Like shutters and hurricane-proof glass and like the Pope-mobile of planes, but for hurricanes and like aggressive wind speeds. But no, it's just a regular plane that they put out into absolutely bonkers conditions.
I think one of the things that people oftentimes ask is, well, that plane must be really beefed up. And I'm like, well, the C-130 is a very structurally very sound aircraft. And so it's not as if, they're adding significant structural reinforcements. The basic airframe of the C-130 is sufficient for the role. They've just added additional instrumentation and communications equipment.
The plane that we fly, the P-3 Orion, was built by the U.S. Navy. We have the only 2 W-designated P-3s, so the WP-3D Orions. But structurally, they're the same as any other P-3 Orion. The only thing we really changed was in the cabin, we beefed up the floorboards slightly because of all the extra science equipment that we put on board. Oh. But the wings, the tail, the engine, same as any other standard Navy P-3.
So one of the reasons airplanes used for studying hurricanes don't need any of this additional reinforcement that our brains are screaming, oh my God, you have to button down the hatches, is that hurricanes have a pretty regular direction of rotation, which means all the winds are generally blowing in the same direction. And so that allows an airplane to actually fly through a hurricane, whereas in something like a thunderstorm, you have much more chaotic wind patterns, which makes it way more dangerous to fly an airplane through it. But none of this means that hurricane planes aren't special, unique, and tailored to do their job.
So one thing that is beefed up from usual aviation is the maintenance schedule. It's like the CrossFit of maintenance schedules. All planes have certain checks and schedules that they need to follow to keep them certified and airworthy. But hurricane planes, for NOAA and the Air Force, they have large teams of mechanics and designers that spend a lot of time keeping these planes in pristine condition. And they also fly with the teams into hurricanes to be on hand to fix anything in flight, according to my main man, Kevin.
Our planes were built in the 70s. The P-3s were built in like 75, 76. Now, granted, there are very few original parts on that airplane. We have a phenomenal team in-house that makes sure our airplanes are absolutely in the best shape they could possibly be. They get a lot of love and care after some storm flights. We have replaced the wings. We've replaced the tail. And we've replaced the engine. These planes have been very lovingly cared for over the years because we do put them into a pretty harsh environment, and they do come back after some flights needing some tender love and care, but we've got a great team to take care of it in-house, and they can turn that plane around in a few hours and get us ready for the next mission.
So Gulfstreams, like the ones that Thomas flies that we've been talking about, are usually private or corporate jets. And of the planes that fly hurricane missions, NOAA's G4 is probably the plane that is the most modified from its usual use, because they're not just, having cocktails and doing really important business calls while they're flying. So since it was designed as a small private jet for rich people and not a military asset like the C-130 and the P-3, it needs a little bit of change.
The inside of the Gulfstream is so vastly different from your, off-the-line corporate jet. And it's kind of funny because all of our pilots go through Gulfstream type rating and training through private vendors. And whenever we get our annual recurrent training done, we're sitting in class alongside of corporate pilots. And I show them the inside of our plane, and I feel like I'm going to bring them to tears because they're used to the wood grain and the leather sofas and all this stuff. They've got a flight attendant who with a full kitchen and all this stuff, and we've got we don't have any wood grain. We have these very, very industrial looking racks and things like that, and they're like, I can't believe it. So that part is kind of funny. I mean, it's such a heavily modified jet. The nose cone, that's why we call it Gonzo, is because it has an elongated nose. And so it kind of takes away from that classic Gulfstream look of the radome in the front. And again, that sometimes when I show people that, it kind of brings them to tears. They're like, oh, beautiful Gulfstream, why'd you have to ruin it? And I'm like, no, this is super cool. We have like a really awesome radar in there.
Let's talk about hurricanes. Now we're getting to the meat of it. I'm rolling up my pants.
No, I love this because we've been talking about hurricanes, Sophia and Matt. Like, everybody knows exactly what we're talking about. Sophia, you certainly have the most experience between Matt and I combined. But let's do a little Hurricane 101, like the anatomy of a hurricane.
Yes. And this would be where I would pull out one of those retractable / extendable sticks to point at my chalkboard and pull down the little thing over the chalkboard.
You're going to just extend your invisible pointer.
An audio pointer. So, a hurricane is a name for a tropical cyclone. It's a rotating low-pressure system, a storm, that forms in tropical or subtropical bodies of water. In other places, it's called a typhoon or just a cyclone. The ones we experience are typically called hurricanes. And hurricane season starts June 1st and goes all the way through November 30th.
Asterisk, approximately.
Asterisk, approximate. Well, that's the season. There's sometimes things outside the season, just like, sometimes you get a really early snowstorm.
Or
I don't know.
Blueberries from Peru.
Or blueberries from Peru when it's not blueberry season here. That's a good example. Anyway, the hurricanes, then have different categories based on their sustained winds, not gusts like the average sustained wind. They start as tropical depressions, which is maximum sustained winds of up to 39 miles per hour. Once they pass that, they become tropical storms. That's anywhere between 39 miles per hour and 74. Once it's over 74 miles per hour, that's officially a hurricane. And from there, we get into the categories of 1 through 5, and that's based on wind speed. So even though the categories go 1 through 5, and a 5 might seem like the biggest and scariest, and it definitely is if it's coming right at you, it's not necessarily the most dangerous. A slower storm that's dumping a ton of water and not fully moving away, or a storm that's rapidly growing and intensifying, those can be more dangerous and, as it turns out, harder to fly through.
Some of the worst storms I've ever flown are like the tropical storms that are turning into Cat 1 and Cat 2. If I see a Cat 4 or Cat 5 that's been a Cat 4 or Cat 5 for like 12 to 24 hours, I'm like, this flight's going to be a breeze. I know exactly where the middle is. The storm's nice and stabilized. It's not going through this crazy intensification period. It's going to be an easy flight. A lot of people don't realize it. It's those small storms that are rapidly intensifying into the big storms that usually give us the good rides.
When you're moving through a tropical cyclone, or while one is moving over you, you'll eventually reach the center, aka the eye of the storm, and that's a little pocket of quiet. The birds are chirping, the sky is clear.
One of the coolest parts of our job is when you're like getting thrashed and you've been bumping around for a while and you can like see on your nose radar, like we're just about to get to the eye. And on the other side of all this gnarly turbulence, we're going to get a chance to breathe, right? And so you go from this like crazy environment, it's loud, you can hear the rain hitting the side of the airplane. And sometimes that like makes it hard to communicate. There's so much precipitation, to this like sunny, quiet. The temperature inside the airplane changes because, a hurricane is a big low pressure system. And you can actually feel that temperature change, the humidity changes. It's this very surreal experience where you go from this like chaotic environment to like peaceful and calm and quiet. As you get closer and closer to the eye of the storm, the winds are getting stronger and stronger and stronger. So you're having to adjust your heading to make a straight line through the storm. We want to hit the eye wall perpendicular, basically 90. We want the wind 90 degrees to the airplane. So making really small adjustments there, trying to maintain altitude, a set altitude that the scientists want us to be at. It varies based on the mission. So the in-flight meteorologist is giving us small course corrections here or there to make sure we're not flying through anything that's really gnarly. Sometimes you can get little tornadoes that spin up in the eye wall, and so they'll kind of steer us around those. They're backing up the flight engineer and the pilot flying by calling out headings, calling out airspeeds, and so it's this really kind of dynamic dance.
The hurricane hunters fly through the storms over and over again to get information about it.
And so a typical pattern for us is what we like to call a rotated figure 4. So if you're looking at a storm from the top down, you can basically see like this big circle with a little eye in the middle. So we'll start at the north side of the storm in the outer rain bands. We'll fly through the eye wall and into the eye. And there, the reason we got our name, the Hurricane Hunters, is we're hunting for the eye of the storm. And really what we're looking for is the zero wind part of the storm. Where does the wind go from 160 knots down to 0 and it changes direction? And our flight directors, our in-flight meteorologists, are the ones that are trying to find it. So they're sitting right behind us and they're giving us like 2 to 3 degree heading corrections. Like turn right 5 degrees, turn left 2 degrees, turn left 1 degree. They'll give us little tracks to fly. And as soon as they find the center where the wind shifts and the wind hits 0, they'll say, mark center. And we'll drop a dropson. We'll mark the location. So now we're in the eye of the storm. We go straight out to the south side of the storm. And again, sampling all the way out with the radar and the dropsons. Then we'll fly what we call a downwind pattern. So, hurricanes spin counterclockwise in the northern hemisphere. So we go downwind, and then we're going to be on the east side of the storm, and we'll go through it again. And we'll do the same thing. And we'll go find the zero wind part of the storm, and we'll see where it's moved. So we'll see how fast it's moving and what direction it's moving. We'll see if the pressure has changed. So if the pressure is dropping, the storm is getting stronger. We're measuring dropsons all along that route to see kind of like where the worst part of the storm is. Then we'll go out to the west side. Then we'll go downwind, and we'll do it again. Then we'll go downwind, and we'll do it again. And we essentially do it as many times until we run out of gas, typically 8 to 10 hours, depending on where the storm is or what the mission profile is.
So, Emily, you're the scientist in this group. These flights are for scientific purposes, and, we did learn a little bit about the scientific instruments that are used to study hurricanes. Our pilots have mentioned dropsons and sons a bunch of times, and this is the part where we're going to explain those. But what other sorts of scientific instruments and equipment are hurricane hunters using, and what do they do?
I mean, as a scientist, you're always looking to learn more information, right? And in the case of these hurricane flights, you're going to learn an awful lot about hurricanes every time you go up because you're collecting more and more data. But I would argue that not only are they for learning about hurricanes, but they're also there for mitigating. So they're there for a humanitarian reason, to make sure that the models are the best that they can be, to make sure that people can prepare. And the real workhorse of these flights in terms of scientific data collection, right? The humans are doing an enormous service. They're being awesome, but they're helped by their tiny little robot friends. So while the dropsons are not exactly robots, I like to think of them that way. Dropsons are these small detectors that are going to collect data as they fall through a hurricane. They're about the size of a can of Pringles with kind of a square-shaped parachute on top. And all of the different kinds of hurricane planes will drop these instruments.
We have a number of different sensors. There's really 2 that are very important for the Hurricane Center. One is dropsons. Those are the little, we call them essentially weather balloons in reverse. We launch them out of the airplane with a little parachute. They fall through all the different layers of the atmosphere, send back temperature, pressure, humidity, dew point, and GPS-derived wind speed from the airplane all the way down to the surface. Very important piece of equipment. We'll launch a bunch of them in all the different quadrants of the storm. We also have a vertically scanning Doppler radar in the tail of the airplane, which is a very unique piece of equipment that only NOAA aircraft have in the United States fleet, that is vertically scanning the storm as we're flying through it, mapping out the vertical structure of the storm.
Other types of equipment, assets, give us information about these storms as they're progressing. For example, you may have seen satellite coverage of these storms on the evening news, but one of the things that these dropsons provide that the satellites don't is, what's going on the inside. And that really gives the modelers a better sense of what's going to happen next than just the aerial view that you get from the satellite.
And the classic phrase, all models are wrong, some models are useful. And I don't mean to say that people who do a lot of models aren't right or don't know anything, but it's that models are just models, and they're only as good as the data that goes into them. And what's amazing about these hurricane flights and the equipment that they bring with them, including the dropsons, is that is the only way to get that information. You can't get it from a satellite, and it's going to make the models better and better, which is why this is such an important job and such an important role that both NOAA and the Air Force play in tandem.
So all of that flying, all of the information that's gathered by the dropsondes and by the other scientific equipment on the planes, by the scientific weather experts on the planes as well, that's all fed into models that then informs the ground response to those incoming storms. It's the real-time data from the storm that people are able then to build a response on.
That's invaluable to make the model that much more exact. And that becomes increasingly important to interest. For example, if you live in Florida or if you have family in Florida, most everyone is familiar with the cone of uncertainty. And that's probably the coolest thing about flying these things is that, especially for a night flight, you land, you go to bed, you wake up again, you check the forecast and the cone has shifted. And it's like, I did that, or it's not just me, it's the whole crew, obviously, but the crew that flew directly impacted, the certainty of this forecast. And if that shifted or if that shrunk the cone at all, it could be the difference between people taking it more seriously and evacuating versus people that are outside of the cone now being able to use their home as like a safe refuge for other people. The possibilities are kind of endless, but it kind of arms the general public with that knowledge of knowing, okay, I need to take this seriously or this storm might not affect me.
Yeah, so if you or your family, or my family, they really depend on the models and the predictions made by the Hurricane Center with this work, because it's directly impacting your safety and your decision whether to evacuate or board up or not. Honestly, that's been my favorite part of this episode and the interviews, like thinking that it's looking scary and then I go to sleep, and in the meantime, Kevin or Thomas or Mark have been flying around and through hurricanes, and then I wake up and because of their information, I feel more calm or perhaps more stressed.
And this is all the work that goes into the meteorology that is being reported out through your local news channels. And so there's a big trickle-down effect on how everybody's using this and all of the different venues in which they're using to report on the predictions so that everybody has access to this information.
I flew C-130s for 10 years doing airlift. I did a lot of deployments to Iraq and Afghanistan. And there were times definitely where you could see the impact of the mission and what we do. But a lot of times, you're hauling, cargo from point A to point B, and you don't really know what your piece in it is. In the mission of the 53rd, in particular with the hurricane mission, we can go out and fly a storm and see the impact in the forecast models from when we took off to after we land, what the impact of the data we gathered is to the forecast model. And that's important. I normally live on the Gulf Coast, and whenever there's a hurricane in the Gulf, there's a lot of people that are keeping their eye on that. It has enormous potential impact to your life. Is this storm potentially coming my way? And so having that sort of impact on a huge amount of the American public is something that's very gratifying.
But the best part of that mission is when you got a big storm out there that's looking like it's going to make landfall in some foreign country or the United States, and you land and you look at the forecast. In the Hurricane Center, there's a little button at the top called discussion. You can click on the discussion, and it's basically the forecaster gets to explain why they issue that forecast. And the best part of my day is when I hit that discussion, it says data from the NOAA Hurricane Hunter shifted the forecast 30 miles to the east, and it's preventing the city of Miami from having to evacuate. Like that right there just like makes everything worth it. You're waking up at 2 a.m, you're flying 6 days straight, you're absolutely exhausted, you're missing all your time with your family and your kids. But just like knowing that one flight really helped out a lot of people in a big community is just extraordinarily rewarding.
Hurricane season is winding down, but the hurricane hunters will be out tracking storms until the end of the season. And they'll be back again next year, making sure that predictions are as good as they can be and ensuring that communities are prepared.
AirSpace is from the National Air and Space Museum. AirSpace is produced by Jennifer Weingart and mixed by Tarek Fuda, hosted by Dr. Emily Martin and me, Dr. Matt Schindel. Our managing producer is Erica Novak. Our production coordinator is Joe Gurr, and our social media manager is Amy Stom. A big thank you to our guests in this episode, Lieutenant Colonel Mark Withee from the 53rd Weather Reconnaissance Squadron of the Air Force, and Commander Kevin Doremus, and Lieutenant Thomas Smith of the NOAA Corps. Additional thanks to the communications offices of the NOAA Corps and the 53rd for their help organizing interviews. And thanks to Sophia Soto Sugar for joining us to guest host, and for coordinating this episode and sharing her hurricane knowledge. For additional content, photos, and more, follow Airspace Pod on Instagram and X, or sign up for our monthly newsletter using the link in the show notes. Airspace is sponsored by Lockheed Martin and distributed by PRX.
So that you don't get to the end and then there is no stinger and then you're like, oh no, I waited and then there wasn't one.